Let's open up some starter code, the abalone shells data. Go ahead, find the link, and then click on the file, save a copy in Drive. That way you have your own copy, and what we're going to do is build a random forest on this data. So let's change the title here to random forest and abalone shells. Okay, so go ahead and run the data itself. You can see it is linked, and then let's take a look at it. Okay, so it's showing up here already. And the general idea with this data set is to predict the number of rings of an abalone shell. And you can see, there's at least 15, there's probably fewer than 7. And so we have a range of values that go in order. Regression would be the correct sort of machine learning group of algorithms that we want to try on this. Okay. One last piece of info as I realize, so this sex here is not a numerical column. We need to convert it into one. And it does have MF and I. Maybe I here is infinite and the sex is not known. And so what I want to do here is actually first, let's get our Y. Y is DF rings. Okay, and then what we're going to do with our X, we're going to set X equal to df.iloc. It's all, we're going to go with the sex one too. So it's all of the rows starting with the 0th all the way up to and excluding the last. But then what we're going to do is we're going to run pd-get-dummies on this. Okay. And then we'll verify that our X looks as it should. Just doing a little data prep here, not too much. And you can see now we do get these sexes, but I forgot the addition in recent years. We want to specify df type. I think it's df dot type. Oh boy. Equals float. It's showing that it's underlined, so maybe it's not df dot type. Might just be df type. Let's try that. Got an unexpected keyword, df type. I don't think it's dot type. I could keep guessing. How do we find out? We can just look up the documentation, dtype. Okay, that's it. Memory coming back. Okay. And so this is fine for the different categories. Okay, so let's now run a random forest on this. First, we're going to go ahead and split the data into a training and test set. So from sklearn.model selection, import train test split. Okay, and we got to call out now our X train, X test, Y train, and Y test. Okay, and we're splitting our X and our Y here. Okay, capital X, lowercase y. Okay, that should split the data. Oh, a little off today here. See the errors. I think it's valuable. Name X train is not defined. Well, because we need to set these equal to train test split XY. Okay, I like to show my errors because you all can see that, even when you do this stuff a lot, everybody gets errors. You're going to get errors. Just learn how to deal with them. You can always look back at previous code, and you can also look documentation up if you are not sure. Okay, so now we have it split into X and Y. Let's get a random forest, okay? So from sklearn dot, now this is actually in the ensemble, okay? It's an ensemble. So we are going to import, and we just start typing random forest. We said this is regression, so we clearly want the regressor, okay? Now let's go ahead and build the model. So model equals random forest regressor. And we need parentheses there. We're also going to go ahead and fit it now on this data, model.fit, X train, Y train, and then we'll test it on the test data. Okay, model.score. Okay, so this is our first test on this data set. Let's see how it does. Now, you can see it could take a little bit of time here, right? I mean, it came out pretty quickly because building 100 decision trees. And it only got, 54 4% of the data is the way you would read that is explained by the model. Okay, let's just see what happens if we try another split. Okay, we're going to run both lines of both coding cells again, and we get something that is pretty comparable. Now, this X here, it could be something that is contributing negatively to it because it's maybe there's not much differentiation with that. So what we can do is we can try to modify our X here to see if it improves it. And so in this case, what we could do is we could just ignore that column and start with the first row. Now, when I do that and I make a change, okay, what I'm going to do here is make the change and comment out the other code. And the reason why I do that is because I don't want to necessarily lose it. Okay, so what you'll see here now, if we look at our X, is just going to have the sort of the physical characteristics of the abalone shell. Not to say that this doesn't help us. I'm just looking at making a change in the data to C, do another split. We'll see what we get here. It's less columns, and we still get something that is about the same. Okay, so this is interesting. Note that it did not improve. It actually got slightly worse. We can try one more. And the one thing I want to do here, let's just change the max depth. This is something that we did before with decision trees. So if the max depth, it could be anything here. It could be overfitting. So if we try, let's just try like 4 and see, okay, that's not better. We could try 2, much worse. Okay, what if we go higher, like 8? Okay, slightly better. 10? Okay, and we're not getting the best scores from this data. Now, I do want to do another model. So from sklearn.linear model, import linear regression. Let's see how it does with just regular linear regression. Okay, so let's just go ahead and write in the code, model equals linear regression, and then model dot, I'm just going to copy these other 2 lines and see how it does. Okay, and you can see it gives something very comparable. So we'll pause here. Okay, challenging data set to work with, but one that we can definitely make progress on.